In this video, we're going to look at the different types of change. Now, in science, all changes can be classified into one of three groups, either a physical change, a chemical change, or a nuclear change. And we're also going to look at the law of conservation of mass, as well as the signs that a chemical change has occurred. So, the most simple change is a physical change, and it's a change where no new substance has been formed. This could be a change of state. So if you go from water, which is a liquid, to steam, which is a gas, you've changed state. In both circumstances, you're going to have water molecules. They're just going to be arranged differently. So we start with water, we finish with water molecules. They're arranged differently, but no new substance is formed. Similarly, if you have a substance and you're breaking it into smaller pieces, for example, if you have a cube of sugar and you hit that cube of sugar with a hammer and it breaks into grains of sugar, you've started with sugar and you're finishing with sugar. It looks slightly different because it's undergone a physical change, however, no new substance is formed. Last year, when we were looking at the particle model, we looked at physical changes, and in particular, physical changes of state. So, for example, ice has a defined structure. The molecules are all touching each other, and it's rigid. When energy is applied to it, that ice melts into water. More energy, it evaporates into steam. When water is in its steam phase, or its gaseous phase, the molecules are floating around. They are not in a particular structure, and there are gaps between the molecules. But you can see that at the start we have water molecules, and at the end we have water molecules. So no new substance has been formed. Chemical change occurs when atoms are rearranged to form new substances. And an example of a chemical change or a chemical reaction is combustion and corrosion. Now, combustion is the chemical name or the scientific name for when we burn something in the presence of oxygen. So, for example, the combustion reaction of propane, which is a gaseous fuel and what is in your fires your barbecues, reacts with oxygen and forms carbon dioxide and water. And we can again write this as a chemical equation where C3H8 plus O2 reacts to form CO2 and H2O. Now you can see that we're starting with propane and oxygen and we're finishing with carbon dioxide and water. So we have a new substance formed, we have a chemical change. Now, the law of conservation of mass states that atoms cannot be created or destroyed. What this means for a chemical change is that we need to start and finish with the same number and type of atoms present. So, if we look over on the left-hand side, you'll see that we have 1, 2, 3 carbon atoms. And after it reacts, we have 1, 2, 3 carbon atoms. We also have 2, 4, 6, 8, 10 oxygen atoms, and on this side we have 2, 4, 6, 8, 10 oxygen atoms. And if we were to count the hydrogen atoms, we would find that they are also the same number on both sides. So we can see that there's been no new atoms of any element created or destroyed. They've just been pulled apart and put back together in a different way. So when we have a chemical change, the bonds between the atoms are breaking and reforming to create a new molecule. Some of the signs that a chemical change has occurred is a permanent change in color, a gas being produced, and often those gases are carbon dioxide, hydrogen, or oxygen, a new solid or precipitate being formed, and energy in either the form of heat or light being absorbed or produced. So if we think back to the combustion reaction, and if you've maybe had a campfire, you'll notice that the wood has a permanent color change. It goes from brown to black. You don't notice a gas being produced as part of the reaction. However, one of the big things when you burn something is that energy in the form of both heat and light is being produced. So therefore, there's 3 good signs that a chemical change has occurred. Now, the last type of change is a nuclear change. And you don't really need to know about nuclear change, so I'll just touch on it briefly. But what happens is the atoms are changed internally and new elements are produced. So you might have two light atoms that are slammed into each other to form a heavier atom, or you might have one heavy atom that splits apart to form two lighter atoms. An example of this is uranium. When uranium is hit with a neutron, it becomes unstable and splits apart. And so when it splits, it can split into krypton and barium, both of which are smaller atoms than the original uranium. So it's producing new elements that are smaller in this case. Now, the conservation of mass still applies to nuclear change, but rather than have the same number and type of atoms, we have the same number and type of subatomic particles. So we don't get any new subatomic particles forming or disappearing. They're just changed in the way that they're arranged. In this video, we've looked at physical change where no new substance is produced, for example, a change of state or breaking something. We've looked at chemical change where atoms are rearranged to form new substances. However, the number and type of atoms does not change, the conservation of mass. We've looked at the signs of chemical change, energy being released or absorbed, a new solid substance forming called a precipitate, a permanent color change, or a gas being produced. And we've also looked at nuclear change where subatomic particles are rearranged to form more elements.